Hello, welcome back. We are going to work with another Excel solver problem. And on the handout, this is practice number 6. And this time we are supposed to maximize the profit of the company. This is a shipping company that charges 1 million per ton, and it would like to maximize its profit given the constraints that it has. So go ahead and enter that information into an Excel worksheet. I already have a file here called containers, and I'm going to go ahead and open that. I actually already entered the data to save time, and this is the information we have that is given to you in the handout. And we have been told that the company has a capacity to ship a total of 100 tons. This is what we've put over here. Also, for each ton, each of the different containers have different volumes, but the total volume that the company can ship out is 50,000 feet cubed. And we've been told that the company charges, or not 10 million, the company charges 1 million for each ton it ships out. So that's the information we've been given. Then in regard to the containers, each of the containers has a different capacity. Container A cannot exceed 30 tons per day, container B cannot exceed 40, and container C cannot exceed 50. And each of the containers also has a volume. So container A has a capacity of 30 tons, but its volume is 550 per ton for each ton. So these are some of the constraints we have that we are going to be dealing with. So we've been told to maximize our profit. So let's go ahead and see how we can maximize the profit of the company. One thing we need to know, in order to maximize profit in such a business, you have to ship the most you can. You have to take advantage of all the containers you have and fill them as best as you can. Sometimes you are not able to, but you want to make sure that you fill them up and ship out as much as you can. That's how you maximize profit. So our total revenue is going to be the basis of this. And total revenue is going to be dependent on the number of tons or the capacity each of the different containers sends out. So let's start out. Again, I just want to save myself typing this work again. So I'm just going to highlight it, make a copy, and I'm going to paste my work here down. Let me first do this. I feel like I wish I had put this work, the tons and what, a little higher, but let me first paste my work. Okay, so there's our capacity, and I'm going to delete what is in here. Okay, so we have our cells here. Let me just move this up so that there's a difference between the input area and the output area. Okay, that will work. So this is going to be our distribution, or maximizing the profits of the company. Remember the other number we did solver earlier, and we said solver is the one that's going to help us to know how much to ship out, how much will each of the different containers have. But we are going to start by putting an assumption. Let us assume that each container sends out or ships only 1 ton. Let's just assume that. We'll put 1 in each of these. Remember, you can put any assumption, whether you want to put 10, whether you want to put whatever figure, even 5 for each of them. It's up to you. Just put in that assumption. The assumption will guide you or give you an idea of what you're working with, rather than working with the blank. Even if you leave it blank, it can also work. I prefer to put in an assumption because solver is going to change that in any case. Okay. I think I'm going to change this to 2 for the fact of I've noticed I have to calculate the total volume and you may not be able to see the difference. So let me change this to actually 5. Let me put them as 5. That's fine. So that's my assumption. I've changed my assumption to 5. And here below, I'm going to put the total capacity. Remember, we're told that the total we can ship out on a daily basis is 100. But if we assume that we send out from each container 555, what is the total we are shipping? So this is total shipped. Okay, what is the total shipped? And in this case, it's going to be a sum is equal to the sum of what has been shipped from the 3 different containers, and we close our bracket and we enter. Okay, so it's 15. Let me just put this in the center. Okay, so that is the first one. Remember, this is a formula. Then if we are shipping out from container A5, 5 tons, it means the volume is going to be 5 times the volume per ton. Remember, here we have the volume per ton. So we are going to use is equal to, we can use is equal to, and we are going to click on this cell times the volume of A. Make sure you are clicking the correct cells, and we are going to enter. And we are going to use the fill handle to drag this down. So whatever is here in B is the 5 tons that are sent out by B times 800, and it's showing that that is 4,000. And for C, the 5 tons sent or shipped in C times 400, which would give us 200. So I just used the fill handle and I dragged this down, and that gives us that. So what is the total we are shipping out? I can just get my fill handle here and drag this across, or I can go ahead and start with sum, but I'm just going to use the fill handle, drag this across. This gives us the total. Pay attention to the formula that is in that cell. It is equal to sum of F10 to F12. This is F10, F11, and F12. So this is a sum. And remember the other constraint we have. The total volume from the 3 containers cannot exceed 50,000 because that is the capacity that can be shipped out. That is our constraint. So we are going to go ahead and calculate finally our revenue. Remember, we said our revenue is actually going to be a guide to our profit. So the revenue, let's call this total revenue. Total revenue, and we click in the cell here, is going to be equal to the total that is shipped out. We click on that cell times the charge per ton. I click on the cell for the charge, and again we enter. So if we ship out 50 tons, we've been told that we shall be getting 15 million, because that's 15 times 1 million. So we are now ready to use solver. Remember, solver is going to help us to decide on how much we can send to each of these without exceeding the capacities of each and without exceeding the total volumes of each. So let me just highlight the areas we are assuming so that you can see those two. Last time we used this color, so this time let's use blue. Okay, so there we have that, and we are ready to use solver. I'm going to click in total revenue, and I'm going to data, and I click on solver. Remember, there is a video in case you don't have solver. a video before this, click to know how to put in your solver. Once you put in solver, you don't have to do it over and over again. So we are going to start out by setting our objective. Here is our cell where we say set objective. I had already clicked on it, but let me just show you how this is done. Click in that cell where you set your objective. You can either remove what is there, make sure you can see your cursor blinking, and you go and click on the cell which you want to maximize. We want to maximize revenue because if we maximize revenue, all factors remaining constant and the cost of shipping is the same, we are going to maximize our profit, which is what we've been told to do. And here where we have the max, min, and value of, we are going to select max because we want to maximize. By changing which cells, make sure you click in that space by changing variable cells and click on the icon to toggle and move that out of the way. And we want to change the cells of the capacity. These are the cells. Remember, we made assumptions on these 5 over here. These 3, we put 5, 5, 5. So we select that, click back on the toggle button, and we are subject to certain constraints. So can we add constraints? I'm going to drag this down. I don't know whether I'll be able to drag down. Not really. Okay, whichever way, I'll use the other method of clicking the toggle button. That's okay. Remember what we said last time. We have 3 parts to this: the cell reference, the one we shall be referring to, and the argument you want to put in, and the constraint. You make sure you click in all the correct areas to do what is required. So let us start with the first cell reference. I'm going to click on this button just to move this out of the way. Let me do this. So that's out. Remember, we are starting with, just make sure I'm in the cell reference. So I click out of this. Actually, I don't need to click away. You can see this. The cell reference is going to be those 3 cells there. Those are the ones we are working with. And we are telling the computer, we want these to be less than or equal to our capacity. So less than or equal to. Some of you may ask, why haven't you said is equal to exact? Because the tonnage is also going to affect us here. We have 2 constraints that we are dealing with. So we'd rather say is less than or equal to. Remember, we are trying to maximize. So the computer will look for the best, even though we've said that whatever is in these cells should be less than or equal to. If maximizing can make it equal to, it will make it equal to these values here. So we click on the constraint and we are going to select the 3 cells. What we are saying is A should be less than or equal to 30, B should be less than or equal to 40, C should be less than or equal to 50. And we're going to add another constraint. And the next constraint is going to be dealing with the total shipped out. We tell the computer, we'll start with the total capacity. This total here, the 15, the total of these 3, we are saying has to be less than or equal to. Click where you have constraints. It has to be less than or equal to the total capacity. So we are telling the computer, whatever you calculate here cannot exceed 100. Good. Next, we're going to add. This time, we're going to put the constraint of volume. We click on the total volume and we tell the computer whatever is in the total volume has to be less than or equal to. We click in the constraint and we click the total volume, meaning that the total volume cannot exceed 50,000. And we are going to add. Finally, we are going to tell the computer to limit this to exact numbers because we are being charged per ton. The question didn't tell us whether it changes if you're shipping half a ton. So let's just put it in as an integer. Though if you don't put it as an integer, that's okay too. Only that your figures will have decimal places because sometimes it's very difficult to get the exact tonnage. So we go ahead and put in our constraint. We say these three over here are going to be integers. Okay, so meaning that they cannot have comma decimal places. And we are going to click OK. And we just check this is what we've put in. And we make sure that we don't have negatives, and we are going to make this simplex linear programming. And we're going to tell the computer to solve this for us. Ooh, good. And we are going to ask it to create an answer because it tells us that an answer was created. And we are going to click OK. And you will notice that we have come up with a schedule that gives us full figures over here. And we have also gotten a report on the side. So that's how we have used Solver today. I hope you have learned from this. For those of you who insist and say that, no, why did we insist on putting an integer? Remember what we said. So the solver constraints are saved. You can go in and remove that constraint. Let us just do that for this one and just see how it would change. So we want to remove this constraint of an integer. So I click on it and I choose the option delete. And I'm going to tell it to solve, and let's see what it does. Again, it has given us an answer, but it shows that there are certain constraints, certain sensitivities and limits that may factor in, as I said, and we are going to click OK. And you will notice that in order to get the exact amount, one of the containers has to get decimals or portions of a ton, but in that way we are able to maximize the volume, and the total shipped is also changed to that. Remember, that's because we removed the integer, and we are able to maximize our profits in that way. Okay, I hope you've enjoyed this. See you in the next video. Don't forget to save.